All right, we have a big example here. We have f of x equals x minus 3 raised to the third, 2x plus 1 raised to the fourth, and we want to find the derivative of this. So in this scenario, let's ignore this for just a second. If you wanted to find the derivative of just this alone, you'd use chain rule. 3x minus 3 to the second times 1. Let's erase that. Bring this back. If I asked you to find the derivative of this, you'd say, all right, this is chain rule 4 times 2x plus 1 raised to the third times the derivative of the inside times 2. Okay, so we know how to find the derivatives of both of these functions, but what's happening with these two functions? They are being multiplied. So since we have two functions being multiplied together, that means we have to use the product rule. So that we have to use the product rule here. The product rule is the derivative of the first function times the original second function plus the original first function times the derivative of the second function. And that can be flipped around because it's plus. But so here we go. We have to take the derivative of this, which is using chain rule, times the original second function plus original first times the derivative. So multiple chain rules going on here. So let's go ahead and do that. So this is going to become 3 times x minus 3 squared times the original first or second function, 2x plus 1 raised to the fourth, plus original first function, so x minus 3 to the third, times the derivative of the second function, and that is chain rule again. And don't think of this as like 4 times this whole expression. You're taking the derivative of this function. So it's 4 2x plus 1 raised to the third times 2. And back here, I'm not sure if I was thinking about this, and I can't remember if I verbalized it or not. But when I took the derivative here, 3 times x minus 3 squared, this is times 1 because the derivative of the inside of x is just 1. So that if you want to write times 1 there, I think I more mentally thought about that rather than actually saying it out loud. But that's just going to be times 1. That's why I didn't write anything down. So I saw the x and just moved on. But yeah, that's just going to be times 1, so I don't have to actually have anything. So it's times the original second, so plus original first times the derivative of the second, so 4, 2x plus 1 raised to the third times 2. So definitely not out of the woods yet. Let's clean some things up. So like I said, I had this 3 times 1, that's just going to be 3. So I'm going to have 3x minus 3 squared, 2x plus 1 raised to the fourth. And then over here, I have 4 times 2, which is going to be 8 times x minus 3 to the third, 2x plus 1 to the third. All right, still not quite finished. We need to do some factoring. Look at the constants, 3 and 8. Nothing I could factor out there, so that's kind of nice. But x minus 3 squared, x minus 3 to the third. We need to factor out some x minus 3s. Let's look at the 2x plus 1s real quick. 2x plus 1 to the fourth, 2x plus 1 to the third. We need to factor out some 2x plus 1s. So looking at the x minus 3s first, how many do they both have in common? Like how many x minus 3s do they both have? They both have 2. This one has 2, this one has 3, but they both have 2. So that means I'm going to factor out 2 x minus 3s. Think of it this way. If I had x squared plus x to the third, and I asked you to take out the greatest common factor, you would take out x squared. Because you'd say, well, this one has 2, this one has 3, but they both have at least 2. So I'm going to take out 2 of them, leaving me with 1 plus x. So I'm taking out x squared from here. That's division. X squared from here, division. Same concept, but with just x minus 3s. So I'm going to take out x minus 3 squared. And then I will, I'm not going to write down the rest just yet because I want to do these 2x plus 1s before we start writing some things down. So 2x plus 1 to the fourth, 2x plus 1 to the third. How many do they both have? They both have at least 3. This one has 3, this one has 4, but they both have 3. So that means I'm going to factor out 3 2x plus 1s. Now we write down what's left over. So on the inside, I took away x minus 3 squared. So this term's out of the picture for the first set here. I'm still left with this 3. Then here, what am I left with here? I took out 3 of those, so that means I'm left with a single 2x plus 1 here. So I took out 3 from 4 of them, so that means I have 1 left. Plus 8, didn't do anything with those constants. And then I took out 2 of these x minus 3s, see that too? So I still have a single x minus 3 left here. And then I took out 3 2x plus 1s. So my 2x plus 1 is out of the picture in that second set. Getting there, but still not quite finished. So here I want to distribute the 3, distribute the 8, and then we'll see what happens. So I'm going to have x minus 3 squared, 2x plus 1 to the third. 3 times 2x is 6x, 3 times 1 is 3, plus 8 times x is 8x, 8 times negative 3 is negative 24. Believe it or not done. I have some like terms I need to combine here, 6x plus 8x, and then I have a plus 3 minus 24. So one last time, hopefully, we'll see. X minus 3 squared, 2x plus 1 to the third. And then I'm going to put this in parentheses now, since we're cleaning this up a little bit. 6x plus 8x is 14x. 3 minus 24 is minus 21. And then from here, I'm actually noticing a very subtle, almost hidden step. And before I show you this last step, I do want to point out, if you're like working on homework in your class and you are doing a problem like this, some textbooks might actually provide the answer like this. Some textbooks might want you to take it a little bit further. It really just depends. Like I've seen textbooks have answers like this, where you could take out these factors. So there is an extra step here of factoring out a 7. Yeah, it's super subtle, something that wouldn't be surprised if you just blew right past, because while I was writing this out, I was about to box this up and call it a day. But there is actually a 7 that we could factor out here, because 7 goes into 14, 7 goes into 21. So I'm going to take out a 7, and that constant is going to go all the way to the front of our expression here. So 7x minus 3 squared, 2x plus 1 to the third. And then I did take out a 7, so that becomes 2x, 14 divided by 7 is 2, minus 3. And then this whole statement here would be our answer. Yeah, so that's a good problem. Good chain rule practice there. A lot happening. This step here, this isn't even calculus, like this whole factoring out. This is algebra. It's just a little bit more complicated because we did some calculus to get this complicated expression. So there is a little bit of some tricks there that you want to make sure you're not making mistakes on factoring out that x minus 3, factoring out that 2x plus 1. You got to be very careful there.